I'm Dohyeon Park. This paper is number 107, enhancement on the entropy coding of the Intra mode in VVC. First, I'll talk briefly about VVC and JBED. Then I explain the Intra mode coding and NPM method in VVC. In this paper, we propose the modification to enhance the entropy coding for NPM. I will state the modification of the idea and details of our proposal. Then, after the performance analysis of the proposed method, I will finish the presentation. In the emerging immersive media services, such as 4K and 8K UHD videos and 360-degree virtual reality videos, sure, we can enjoy the services on the mobile. So more efficient video coding technologies are still demanded highly. Accordingly, ISO, IEC, MPEG, and ITUT BCAG found a joint video expert team called JBED to develop a new video coding standard beyond HVC. And the new video coding standard is named as Versatile Video Coding, VVC. JBED targets a bitrate reduction of about 15% at the same subject quality compared than HVC. Moreover, as the name implies, it should be able to cover the usage in multi-purpose services. So, JBED has a plan to release the FDIS on October 2020. JBED has been releasing the reference software called BTM with yearly adapted tools in each JBED meeting. After JBED San Diego meeting, BTM 1 is released firstly. After JBED Ljubljana meeting on July 2018, BTM 2 is released. After JBED Marrakesh meeting on January 2019, BTM 4 is released. Currently, BTM 5 is the latest version. This below graph shows the performance of all BTMs which are released until now. The performance is over the HN16 of HVC reference software. The x-axis reference the BTM version, and the y-axis reference the saved bit rate. Performance of BTM 1 is about 4% bit rate saving in all Intra configuration. Since BTM 1 is the starting point based on the cleanup version of HVC, it is remarkably lower than other versions. On the all-Intra basis, BTM 2 performance is about 18% coding gain. BTM 3 performance is 19%. BTM 4% is 21%, and BTM 5 performance is 23%. The gap between each version is roughly 1 or 2% only. It means that the performance of Intra prediction has reached some point. In other words, it becomes difficult to obtain a noticeable gain of Intra tools. But we'll keep going. JBED has extended Intra prediction modes for VVC. For example, JB adapt the 67 intra-friction mode to provide more dense and wide angular intra-friction. Then HVC, H.Yuxa AVC and HVC, each of which support 9 and 35 intra-friction modes respectively. 67 intra-mode prediction includes 2 non-angular modes, which are Frana and DC mode. And it also includes 65 angular friction modes. Below the figures show the dense and wide intra-friction in VVC. By the way, if you look at the figure for wide intra-friction, it looks like the number of intra-mode is increasing. However, wide angular mode can reflect the general intra-mode depending on the shape and size of the current coding block. So even though wide angular modes are applied, the current block is fixed to 67 intra-mode. Nevertheless, the between overhead is increased to signal the extended intra-mode. It means that efficient intra-mode coding method becomes more critical. Many video codecs have conventionally adopted the most probable mode, NPM, to encode the selected intra-mode efficiently. VVC also adopt the NPM method. NPMs are distinct modes from general intra-mode. They are selected by utilizing the correlation between neighboring intra-modes. In other words, NPMs can be derived from neighboring intra-modes. To support all intra-modes and to enable the entropy coding, first we should change the mode index to a binary code word. For the NPM index, the truncated unary code is used, and for remaining modes, fixed length code is assigned to the index of remaining, shown as the right table. Left table shows the example of truncated unary code, and we can see the tendency to assign fewer code words to lower index. That is, the lower NPM index could be selected frequently. This page shows the process of NPM derivation in VTM2. The number of VTM2 NPMs is 3. It is binarized by the truncate unary code, and 64 remaining intramode is coded by the fixed length code. I'll show the figure. If left intramode and above intramode are the same to below, left mode is non-angular mode, then NPM 1, 0, 1, 2 are assigned prana this particular mode, respectively. Go back. Left mode is not a non-angular mode, then NPM 0, 1, 2 is assigned left intermode and left plus 1 mode, and left minus 1 mode respectively. Go back to the first condition. Left mode and above mode are not the same. NPM 012 are assigned left mode, above mode, and one mode among Frana, this particular, respectively. The process seems quite simple. A 3 NPM method can keep the complexity of the NPM list generation low. In VTM4, the number of NPM is 6. NPM indexes are binarized with truncated unary, and 61 remainings are binarized with truncated binary code, which are assigned 5 or 6 code words. This figure looks more complicated than 3 NPM. Okay, its left mode and above mode are the same, and left mode is angular. The NPM is allocated in the order of left mode, Frana, DC, left mode plus E, left mode minus 1, and left mode plus 2. If left mode and in second order, left mode and above mode are the same, and left mode is non-angular, or left mode and above mode are not same, and both methods are non-angular. The NPM is allocated in the order of the left mode, not left mode, vertical, horizontal, 45 degrees diagonal, and 135 degrees diagonal. If left mode and above mode are not the same, and one mode is angular only, the NPM is allocated in the order of left mode above, not min mode, max mode plus 1, max mode minus 1, max mode plus 2. If left mode and above mode are not the same and both modes are angular, the NPM is allocated in the order of left mode, above mode, Frana, this max mode plus 1, max mode minus 1. There is a trade-off between reducing the complexity and increasing the performance. So JBED thought that 6 NPM is better trade-off. There is a common point of 3 NPM and 6 NPM. It is that the first index of the NPM indicates the intra mode of the adjacent position. It shows that the correlation between the current block and neighboring block is high. The current design of NPM list generation makes the NPM index to indicate the left neighboring intra mode. Also, current block tends to be similar to adjacent block. The selection of NPM index 0 has half probability, which is shown the below graph on the no condition. So the bypass coding engine is used for first code of NPM index instead of regular coding engine. We want to increase the probability that NPM index 0 was chosen. So we analyze the probability of NPM index under various conditions. As shown in the graph, under the condition of left mode and above mode are the same, the probability of the first bins of MPM index to be 0 is 0.8. Since regular coding has better coding performance than bypass coding when the probability of the certain bins occurrence is biased to 0 or 1. If the neighboring intermodes are the same, the bypass coding may not be efficient for the encoding of the first bin. The graph shows the completion rate of the regular arithmetic coding engine in VVC. The input of the regular coding engine is the randomly generated bins with a specific probability. The number of generated bins is 10 kilo bins for each probability. The completion rate is that the number of the output bits divided into the number of the input bins. As the probability increase or decrease, the completion rate increased logarithmically. If no condition, no gain is confirmed. That is the reason for bypass coding is used for the NPM index. However, in the condition of the left mode and upper mode are the same, there is some gain. So we propose using the regular coding mode for the first bin of NPM index instead of the bypass coding mode, considering the observations. This figure is the proposed entropy encoder. Firstly, binarizer convert NPM index to the truncated unary code word. Then, for the first code of the code word, adaptive coding engine selector checks the left block and above block. Then, if the left mode and above mode are the same, the code will pass the regular coding engine. Otherwise, the code will pass the bypass coding engine. This method can be implemented on both 3 npm and 6 npm. The proposed methods are implemented on top of the VTM2 and VTM4. It is evaluated with Intra configuration and the JBack CTC. Each numerical result of the bit rate is the average result of the classic specific sequences for 4 QPs of 22, 27, 32, and 37. Or experimental results are compared over the anchor of VTM2 and VTM4 respectively. Experimental result for 3 npm shows 0.1% bit rate gain without increase of encoding and decoding runtime. Experimental result for 6 npm shows the 0.05% bit rate gain without runtime change. Lastly, this is conclusion. The proposed method adaptively applied either regular coding mode or bypass coding mode to code the first bin of NPM index according to the predefined condition of neighboring Intra mode. Two versions of the VTM2 and VTM4 were used to verify the proposed method with the different numbers of NPM. As an experimental result, average 0.10%, 0.11%, 0.12% bit rate saving for YUV components without encoder-decoder runtime change over VTM2. Average 0.05%, 0.08%, 0.07% bit rate saving for YUV components without encoder-decoder runtime change over VTM4. We think that this result shows noticeable gains without complexity increase. Thank you.